Hi, my name is Vinu. I'm a postdoctoral fellow at Department of Systems and Computer Engineering, Carleton University. Our advanced real-time simulation lab recently took part in AEC Hackathon online, and this presentation explains about running complex simulations on BIM models. The API we built is called BIM2Devs API, and it uses Autodesk Forge and Cadmium Simulator. Our team comprises of students from ARS Lab, experts and practitioners from Spain, Brazil, Germany, USA, and Canada. Currently, our research group is making a digital campus of Carleton University with real-time simulation for optimizing building operation, performance, and management. So our main goal is to extract the building information in a format that is readable in Cadmium Simulator and visualize the output results back in the BIM model. We have a repositories of formal models in Cadmium Simulator like CO2 or evacuation model or spread of airborne particles. Our visualization is mostly 2D and lacks contextual visualization. So we would like to integrate this output results in BIM models for contextual visualization. During the hackathon, I attended a workshop conducted by Jaime on Autodesk Forge and found it feasible for our implementation. We wanted a tool that would provide easy interaction and access to the repositories of formal models generated by Cadmium Simulator for architects, and likewise for the simulators to have a beautiful visualization. So I came up with a conceptual model where the designers or engineers are able to select the Revit models and define the type of simulation they would like to see, like CO2 levels or the spread of airborne particles inside the building. And then the system generates an output that is readable for Cadmium Simulator. Then we would like to visualize the output results back in the BIM models. Based on the type of simulation, the data needs to be extracted at different levels, like elements, wall, space, doors, or zones or rooms, buildings, and masses. For example, at a campus level, we may need only the buildings or massing, but for CO2 levels, we need more detailed data like vents, windows, door, etc. So currently, the format that we use to define the building space in Cadmium Simulator is text to image and image to a JSON file. But we do not have any models or data directly extracted from the BIM model. So the BIM to data extraction process was implemented by Griffin, Kevin, Thomas, and Saif. So our goal was the end user to have a simple user interface where they are able to click on CO2 level or the COVID model, and then the system processes and sends the necessary data to the Cadmium simulator. So initially we started with a bounding box method. When the user clicks on this, it was able to generate the data. But the issue that we faced is if we had a diagonal wall or a curved wall or any complex shape, then the bounding box method was not working. So we moved from bounding box method to an OBJ file format, and this helped us in extracting the necessary data in the format for the Cadmium simulator. So initially worked on a very simple model, and it did not pose any problems. But once we moved to a well-defined office model, there were certain issues that we faced. For example, this office used curtain walling, and then there were doors in the curtain wall. And when we were extracting the data, the doors were still being read as wall instead of dose. So hence we had to go back to the Revit model and redefine the dose that were part of the curtain wall with a different name. So it was getting extracted as a dose and not as wall. Then the second part of our implementation was data visualization. This was implemented by Jack, Mitali, myself, and Bruno. The cadmium simulator gave an output that consists of time step, and it had XY positions, previous state and current state. And then we would like to map this data back to the BIM model, to a cell or a grid method, or to elements or objects like a person moving through the cells. So we decided to use the example in the Autodesk Forge point clouds, as it seemed more feasible for our ideas. So this was our first visualization model. Here we actually tried to use the CO2 levels in Z direction as well. But then you can see we had issues where the walls that did not carry any CO2 levels were getting drawn as well. So we just had to filter those data to make the visualization clear. So this is a final product. So an user can click on the CO2 level, and then it will extract the data for the simulator in the necessary format. So this actually achieves our initial goal of giving an easy user interface interaction, where the architects don't need to define any complex equations or choose models, but they can just select the type of simulation that they would like to perform, and the system just extracts the data for us. So currently for this hackathon, we only implemented the CO2 levels, but we would be adding other models like airborne spread particles, as well as evacuation models or pedestrian models into the simulator. So this is an example of our final data visualization. So after the simulation is run by the cadmium simulator, it is stored in the database, and the system is able to read the data. And with a clear click on the play, we are able to see the visualization. In the future, we are planning to improve the user interface icons. But for the hackathon, we just simply used a play button. So this is another example of the visualization, which shows how BIM model helps us to understand the data clearly. So you can see where people are more occupied at the desk space. We can also see the increase in CO2 level. So this gives a very clear contextual visualization. So this is just a beginning of our BIM to Devs API, and we are currently trying to work on more integrating more complex models and real-time data collection. So if you would like to know further details, you could contact me, Vinu Rajus, or Professor Vena. Thank you.